Good afternoon, good morning, ladies and gentlemen. Thank you for joining us today. Today we will have the very exciting topic of LED and their use in area and floodlights. The topics that we'll discover today on these two types of fixtures will be a little brief history of this lighting category, why LED. We'll also talk about the environment and not just the type of environmental positive impact from saving energy that everybody kind of uses to make their device or product an energy efficient product by reducing the wattage a little bit, but I'm talking about a real positive environmental impact. And let's start with a little fun here. Quick history and major milestones in the area lighting category. Going back to the 15th century, using such things as beeswax and fat from animals, London started installing streetlights. Close to 1700, Louis XIV installed almost 3,000 lanterns in the streets of Paris. In the 1760s, New York started putting up light posts using whale oil. 1792, in Europe, they started using gas-powered lanterns. 1807 was the first time, right in the Pall Mall Square section of London. We have to give kudos to Pittsburgh, who supplied a lot of this information via a white paper that they put out several years ago. Pittsburgh was using whale oil streetlights back starting in 1816. So moving quickly through, Wabash, Indiana being one of the first cities in the world to be electrified. New York City probably the first major in the world. And some other milestones. 1948, mercury vapor was invented, and it was adopted widely for roadway and area light applications. About 10 years later, the Cobra head mast-style light fixture that we've become accustomed to in roadway applications first started being installed. And by the 1970s, high-pressure sodium was being used in these types of fixtures. Still today, there are high-pressure sodium falling quickly mercury vapor due to the energy laws that more or less ban that lamp going forward. Some have used induction in this application since that time, but today the real exciting technology for these applications is certainly LED. Let's talk a little bit about the advantages of using LED in this application. You know, basically we all know it's an energy efficient device, but 50 to 90%, and you're going to get 60 to 90% with a MaxLight product, and you're going to get the same light output. Now, for us all to be on the same page, when we say same light output, I am not referring to the lumen count of a bulb. I'm referring to foot candles on the surface, what they call delivered lumens. And obviously the operating costs over the longer life are lower. LEDs are 2 to 3 times longer life than the traditional light sources that are used in this application, except maybe induction. And induction has some issues with cold weather, and it certainly has photometric issues. You can't sculpt induction lighting. It's just a big blob of light. So when you try to do cutoffs and things like that, it just makes it less efficient. Things vary from laboratory to laboratory, but it's estimated 20 to 30 years is how long LEDs would last. But a practical use of LEDs is about a 30% depreciation point. That's referred to as L70. And it's a lot to do with the quality of the product, which is why you want to look for things such as lighting facts and DLC recognition and certification, because that helps you to understand that you've got a quality product. The reduced relamping costs of LEDs is also a great contributor through the maintenance means. And theoretically, unlike the bulbs that are used in the incumbent technology such as high pressure sodium and metal halide, we don't have LEDs going through the landfills. They can be 100% recycled, and I hope to see that one day a good initiative is put together for that. Now, even though we can recycle LEDs, let's assume they are not recycled and they go into the same landfills, there's no toxic metals or chemicals in these products. A major pitfall for the traditional light sources is the high quantity of mercury, lead, and other toxic chemicals that are in each of these lamps. While a single bulb might not be that dangerous, when you look at an estimated 500 million streetlights worldwide that are being cycled every 3 to 5 years through the landfills, that's a huge amount of toxic waste going into the landfills. And by the way, the United States, as you probably would have guessed, is the number one user of these types of lighting. As a matter of fact, we use in roadway and area lighting applications more terawatts per year in the United States than most countries use in total terawatts in Europe. The quality of light, the type of light, one term, monochromatic light. This is a full spectrum light, or at least a wider spectrum light than what you get from the traditional light sources, and it's basically a higher quality of light that allows you to see colors better, and it's just better aesthetically. I grew up in New York City, and in my neighborhood growing up, our curfew was when the roadway lights went on. When the street lights went on in front of the apartments, every kid in the neighborhood had about 5 minutes to get back into the house. That was how it was done back then. And I recall, I believe there were high pressure sodium, the distorted colors of the cars. You could barely tell the difference between a green and a blue car, and colors are completely distorted under that type of light. And certainly LED has the capability of much higher CRIs and also the higher Kelvin temperatures, which contribute to a better aesthetic. Another advantage some see maybe as a disadvantage is the fact that LEDs don't burn out. Rather, they gradually diminish over time. The industry accepts as a standard more or less L70, which means that that product needs to be replaced at a 30% depreciation time. I happen to know that there are major corporations, national corporations, that have set up, for instance, an L60 corporate standard. So in their lighting, they're going to wait for a 40% depreciation before they replace the fixtures. And obviously, if they're doing it right, they're starting off with higher lumens so that they get the longer life package. The point is that one should choose the point at which the fixture needs to be changed, and it should be somewhere in the L70 to L60 range. And by the way, if metal halide lamps were held to the same L70 standard as LED, metal halides would be rated at about 6,000 hours. So that's just a quick comparison for you. Another advantage, maybe not so much in the area light, floodlight arena, is the fact that they can be rapidly cycled, turned on and off without any negative impact, where with other light sources that can have a negative impact. And the instant on, as you know, most HID lamps have a 3 to 11 minute dwell time, delay time when you turn them off and back on again. Certainly that does not happen with LEDs. They have nearly an instant on. Another major advantage for LEDs, for those of us in cold weather environments, is that LEDs are relatively unimpacted by cold weather applications. It's the main reason you don't see things like induction and fluorescent nationally, because in extreme colds, these types of lamps don't work at all. LEED certification for your building and your building and properties is becoming more and more sought after here in this country. As you may know, the LEED certification program is a enticement, a boasting point to be able to say that your building is LEED certified. There are many levels to LEED certification. I believe the top level is platinum certification. Certainly LEDs used interior and in your exterior contribute towards your LEED certification. Now, we've talked a lot about environment, and I just want to pull out one other point. You know, coming from a background with a long history of fluorescent, particularly CFLs, I know mercury is a delicate subject in different areas around the country. And frankly speaking, I've taken personally a lot of abuse, and manufacturers like Maxlight and others who are doing the right thing for the environment by having environmentally friendly products still get beat up for having mercury as a component of our products. Now, if you look at a typical 70-watt metal halide lamp, that has about the same amount of mercury as 2 CFLs. And if you look at a 400-watt metal halide lamp, there's more mercury in one 400-watt metal halide lamp than in a case and a half of CFLs. But there's no hue and cry about this technology. So going forward, I want to flip this around and talk about mercury and its negative impact on the environment. America brings in literally hundreds of millions of tons of mercury in our products, mostly lighting, into the country every year. And the use of LED will certainly put a damper on that. And that's not to mention the mercury that comes from the smokestacks at our fossil fuel burning power plants, coal and oil. puts a good percentage of, I don't remember off the top of my head the kilowatt rate. I believe it's 0.012 milligrams of mercury per 100 kilowatts of power generated. So it's a small, tiny amount, but it adds up quickly. Let's jump over to the cost of ownership of an LED type of area light type fixture versus the incumbent technology and HID. You know, these graphs are kind of general, and your particular installation or job depends greatly on the old wattage, the new wattage, your maintenance costs, etc. I raised this slide without any details to remind you that MaxLight will be very happy to provide for you a cost of ownership analysis on your job using our products, including maintenance costs, return on investment, etc., including even environmental impact. You know, I found it interesting that I was asked to put together a 30-minute or so presentation on the subject, and, you know, I had a little trouble understanding what the difference was between an area light fixture and a floodlight fixture and the fixture itself. And the conclusion I came to is that they are the same fixture with different mountings for different options. And an LED, that is more true than ever. Area lights are generally being used in landscaped areas, public parks and the like, but mainly in parking lots, which I failed to mention there, forgive me. And the floodlights, it's just a broad beam meant to light up as large area as possible with a very intense light. Now, in the case of LED, and in the case of many LED outdoor fixture manufacturers, the fact that we have different mountings puts the fixture in completely different categories. We have identical fixtures in wattage in the light engine construction that are identical. The MaxLight floodlight fixture, say 70 watt or 100 watt, is identical in every way to the MaxLight area light fixture, 70 watt and 100 watt as an example. The only difference between the two is the mounting and how it mounts. With an area light fixture, obviously it's going to be on a fixed rigid pole, and almost always it is parallel to the surface, to the ground, and illuminating straight down. Where with a floodlight fixture, you might want to have a broader array by tilting the fixture back, where you'll get more intense lumens directly below the fixture, and it fades as it goes off into the distance. These would be found maybe mounted on the side of a building, possibly on a pole with an arc, but generally either on the side of a building facing outwards or on the ground facing upwards towards the building for either ambiance and or security.